This is the second video. This is the video about the doubly linked list. In this PowerPoint, we will learn what is doubly linked list and how to define the doubly linked list in Python and what is positional list. The doubly linked list. And the doubly linked list, we see this figure. So it is a trend. And the idea of this linked list is similar to the trend. A doubly linked list, provides a natural implementation of node list ADT. So nodes implement position and store the element and then link to the previous node and link to the next node. So this is a node and this is the element. We want to check what is the previous node and what is the next node. There is a special trailer and header nodes. So there is a header and there is a trailer. So we need to make a node. So this is a special node. There is nothing inside the header. Nothing in the header. It is only to indicate that it is the head and also nothing in the trailer. It is to indicate the this is the end of the sequence, and everything will be indicated in the nodes, and this is sequence. And in the sequence you will see that this is the element. Let's say this is the lion and this is a bird, this is a frog, and then this is the horse, and we know that this is the first element. This is the first element, so it is connected to header, and then it is connected to second element, and the bird is connected to the first element, and so on. So a doubly linked list application, you can see like maybe similar with the previous one, but it is more a connection between next and previous. Even though in the image viewer, you can also see the next and previous button. Yeah, that's also similar. That's how we can define the doubly linked list. And the browser, yeah, types which allow you to hit the back and forward. So if you have the back and forward functions, then it means that they try to apply this doubly linked list. And this is for the undo redo functionality. So if you look at the word or handle, those kind of thing, they refer to the undo and redo. They also have this kind of function. And in this case, they use the doubly linked list. Okay. Now, we can see every kind of data structure. Okay. Every of the data structure, they will indicate the insert, okay, or the insertion and delete. So they want to know whether the insert operation is optimum, is efficient or not. If it is efficient, then it is good. If it is not efficient, then they will change with another data structure. So in this case, in the insertion of the doubling linked list, we want to insert a new node, and the new node, let's say the Q is the new node. So it is in between the P and its successor. So we have this sequence. We have header. This is header, and this is filler. Okay. And then we have the element like A, B, and C. Okay. So we have, this is a sequence. So P is this node. And then I want to put Q in between this P and this C. So in order to put a new element, we need to check the connection. So if P, now the element P is connected to the element C. So this is the next and this is the previous. So we will remove this connection and then we will put the new connection between P and Q. We will put the new connection between Q and this node. Then the end of the structure will be something like this one. Okay. And for the deletion, we will remove the P. Okay. In this case, this is the P. And then we want to remove this one by looking at the trailer. The end of this one is the trailer. So we have the node of the trailer and we have the node of this element. Then P, which is D, will be removed. And if it is removed, there is a connection directly from C to the trailer and from the trailer go back to C. And then we can remove this one. Now the final data structure will be like this one. This is the code in the Doubly linked list or in Python. The class of Doubly linked list, it includes the class node. Okay. So if you still remember from the link stack, you can see this node from the link stack. You can construct the initial code by creating a header, trailer, and then the header next, it means the trailer. If there is nothing inside the element, okay, so it means the header, and then next is the trailer. So the first will be header, and then the next will be trailer. This is the initiate, okay, or we call this is the constructor for the initial data structure of the building list. Okay, and then the trailer, the trailer previous is the self header, and the size is 0 because we have nothing in the building list. So we can check the length, we can see whether it is empty or not, and then we can have the insert between. It means whether we want to insert between the predecessor and successor. So what is the predecessor and successor? So the predecessor means before, and successor means the next. Okay. So predecessor is the previous one, and successor, it is the next. Yeah. So we insert in between, then the predecessor of the next will be the newest, and the successor of the previous will be the newest. Okay. So the predecessor, so let's say if I have a new node, this one, then the predecessor of the next, okay, the predecessor of the next will be the newest. This is the predecessor of the next will be going to the newest, and the successor, in this case, the previous will be connecting to the newest. So this is the newest node. Okay. So that's the meaning by these two. If we delete node, then we need to check what is the predecessor, and what is the successor, and then we will change the predecessor next with the successor, and we will change the successor with the predecessor. So if we have this one, at first we will check the predecessor. We want to remove this one, then we want to check what is the previous, and we want to check what is the successor. After we know the predecessor, after we know the successor, so this will be directly updated. So this will be connected with this one, and this will be connected with this one, and then the size will be minus by 1. Then yeah, we will check the element, and the next node and the previous node and the element will become none, so we will remove it. So the performance of this doubly linked list in the space aspect, it is on, and then for each position in the list, it is O1, and then for all the standard operation, for example, the standard operation is insertion and deletion, then it is O1. The concept of doubly linked list is useful for the positional list. The positional list means we want to provide a general abstraction of sequence of elements with the ability to identify the location of the element. So this is what we call as the positional list. A position acts as a marker or token within the broader position list. And a position P is not unaffected by changes elsewhere in a list. So the only way in which a position becomes invalid is if an explicit command is issued to delete it. So if we want to delete, if we want to remove, or delete, then it affects the position. Yeah. We will have the position instance. It is a simple object. So there will be a object of position, and it supports with the following method. So if we to use P, let's say P is the position. P is the position. So we want to know in that position what is the element. We get P dot element. It returns the element start at position P. So we always use the P to indicate the position. There are some operations in this positional accessor. For example, L dot first. So we want to know what is the position of the first element of L. So L, yeah, we can use list, or we can use another kind of data structure to represent this L. L dot last. So we want to know the last element, L, and it returns none if it is empty. We want to check what is the element before P. Okay, so return the position of L immediately before the position P. So we want to check also the after P. So we want to check the position of L immediately after position P. And then is empty. Is empty, whether we want to check whether the position is empty or not. And we want to check the length, we want to check the iteration. So I think the length means the size, and in iteration it is the forward iterator. So we want to check the next, we want to check the next, we want to check the next, and so on. And in the positional update operation, so we can add the first, we want to insert a new element at the front of L. It will return the position of new element, and then we can add the last. We can have a new element at the back of L. And then you can also add before and add after. Add before means we will insert a new element E just before the position P. So it means we have the P as the position, and then we want to put the E before P. Add after means we want to put E after the position P. Element E just after the position P. Replace P. Replace means we want to change a position P with element E with some other position, or returning the element formerly at the position P. If we delete, then we will remove. Okay, we will remove and return the element at position P in L. So let's see the example here. So the table shows a series of operations on initially empty positional list. So L is empty at the first time. Okay. And then position, to identify position, variables such as P, Q are applied. So in this example, we will have P and then Q and then R and then S and then T and U and so on. Okay. So we will use P, Q, R, S, not A, B, C to make it easy. And for each exposition, the list contents are displayed with subscript notation to denote its position. You know, subscript. Okay. So subscript means like this one. It E. Yeah. Okay. This is subscript. So the location is in the below. Okay. So we have the subscript. Do you know superscript? Superscript means we have something like uh, 8p. Okay. It is ahead or in the top. If it is below, yeah, we call it, this is subscript. If it is on the top, okay, like this one, this is superscript. So this is subscript. Okay. So the operation at the first, we want to add last. Okay. L will be added. So we have 8. The element is 8. Okay. And then the position is P. Okay. So we will return a value which is P. So the position P. If we want to check what is the position in the first, then we will return a value P. Okay. And the L, the positional list, is still the same. If we want to add after P, okay, so add after P, then the element 5 will be added, and then we will use Q. Okay. So as I mentioned before, we use P, Q, R, S for the position indication. Then P at P and 5Q. And then next, we want to see before. Okay. We want to see before Q. Before Q is P. Okay. This is Q, and before Q is P. And then we want to add before Q with element 3. So we know the Q here. So before Q, we want to add a new element 3. So as I mentioned to you, we will use the P, Q, R, S, T, U, and so on. Okay. Then the next position is R. So once we add before Q, then we will return the R. We want to check the position R and what is the element of the position R. Then it is 3. We want to check after P is R. Okay. So after P, you know the position is R. So the return value is R. And we want to check what is before P. Because P is the front, then of course there is none. Right? And then at first here, we want to know that the first position is P. And we want to put a new element 9 at the first of this list, or at the first of this positional list. Then S, okay, S now has been added. So the position S, now we have the element 9. So the return value will be S. Let's delete the L dot last. The last element is 5. So we delete the Q, okay, the positional Q as well. We will remove it. And if we use a replace, replace P with 7. So the P, okay, the element P previously is 8. But we will replace this one with 7. So the return value is the old element. So the old element is 8. It will be showing that 8 now will be removed, and now it will be replaced with 7. So this is the positional list in Python. We create the class, and this positional list, it was based on the doubly linked list. So you can see this one is the inheritance. We already create the doubly linked list class, then can inherit all the things from the doubly linked list. And the position, in the position, it is the initial or the constructor. It contains the container and not container. Yeah, we will. You can see it is a yeah, kind of place, okay, to indicate the position. Let's say the P, Q, R, S is a kind of container, and then you can define the node. The node means the node that you already have from the previous one, node, from the node class. And then we want to see the element, okay, and then we want to check whether it is equal or not equal. Okay. EQ means equal, and NE is not equal. Every time we will check only the equality or not equality for the element in the position. We will have the validate. Validate, it means we want to validate whether the position, okay, the position is available or not. So if not is instance, so if it is not in the position, is instance. So it is about how to check whether P is an object or not. P is an object or not. So if it is not validated, then it is error. If P dot container is not self, okay, so it means if the P is not in the container, so let's say this is the container. If the symbol or this one is not in the container, then it is error. And then if P dot next is known or it is not available, then it is P no longer valid. And then we want to know the position. So we want to make the position of every node. So if the position, okay, if the node is header or trailer, then the indication is none. So nothing in the element. If there is an element, then the self dot position is the node itself. The other thing is the same with what I explained before. First, so we want to know the first position. Last, we want to know the last position. In this case, we are using the header for the first, and for the last, we are using the trailer. And then we want to check the before and after. Okay. So at the first, before we check the before, we want to validate whether P is available or not. If P is validated, then we want to check what is the position in the node. After, okay, we want to check also what is the next position after we do the validation. The iteration. The iteration means we want to check based on the iteration on the sequence. Okay. And as you know from the previous uh, operations, we can also insert between. Insert between means we can insert the element E, predecessor, and successor. Okay, so if you know before, the predecessor means the previous, and the successor means the next. Okay. In this case, we are just calling the super. Super means the superclass. So insert between the E is the element between the predecessor and successor. At first, so at first we want to put the element E in the first position. So insert between header and the header next. If it is in the last, then we will put the element E in the trailer between the trailer previous and the trailer. It at before. So at before means we want to check the P first, check the element P, and then insert between the original dot previous and the original. So this is the original as the P. And then after, add after means we want to check the P first, and then if we know that P is available, then we will check, we will put insert between original, then original next. If we want to delete, then first we will validate and then delete the node. If we want to replace, okay, then yeah, we will replace after we validate the position. If the position is validated, then we remove the element from the position. Okay, there are variants of the linked list. So you already learned about the singly linked list, about doubly linked list. Actually, there's also another linked list. We call it circular linked list. Okay, but I have not explained it well. This figure shows very simple example about the circular linked list. In the circular linked list, so the head is available, but the last node, okay, the last node is connected to the head. The last node is connected to the head. It means it is always circle. It is always a kind of circle. That's why they call it a circular. Okay. There is no code to express the circular linked list. If you have interest on the circular linked list, you can learn and check the other code by yourself. Okay, this is the end of the video. Thank you very much for listening.